Hi, welcome to Dr. Zahid Math. Many students requested, teacher, can you explain what do you mean by diagonally dominant as a video? So I'm doing this video for those students or subscribers, you can say like that. So what do you mean by diagonally dominant for a system of equations? Here system of equations, I'm going to take 3 by 3. Let me take the example a11x1 plus a12x2 plus a13x3 is equal to some b1. And a21x1 plus a22x2 plus a23x3 is equal to b2. And a31x1 plus a32x2 plus a33x3 is equal to b3. This is a system of equations. Now what I want to do, I want to say this is diagonally dominant. If I want to say this diagonally dominant, it means each diagonal element. What do you mean by diagonal element? This is the leading diagonal element and this is the leading diagonal element, the coefficient is the leading diagonal element and this is the leading diagonal element. This leading diagonal element must be greater than the sum of the absolute values of other elements in the same row. What do you mean by that? Yes, absolute value of A11 must be greater than, not greater than or equal to, greater than absolute value of A12 plus absolute value of A13. Similarly, absolute value of A22 must be more than absolute value of A21 plus absolute value of A23. And absolute value of A31 must be more than absolute, not A31, it's A33. A33 must be more than A31 plus absolute value of A32. Again, I'm telling this absolute value is more than the sum of this value plus this value. And this absolute value must be more than sum of these two values. And the third one, this absolute value is more than the sum of A31 and A32. If it is like this, then it is called diagonally dominant. Again, I'll repeat in words. What do you say? Each diagonal element must be greater than the sum of absolute values of other elements in the same row. Clear, everybody? Other elements in the same row. What is the importance of this, teacher? This one ensures convergence of Gauss-Seidel and Jacobi methods. Again, I'm telling, it ensures the convergence of Gauss-Seidel and Gauss-Jacobi methods. If it is not diagonally dominant, you can rearrange. Rearrange means swap the rows to make it dominant if possible. Okay. Why, teacher? Do I need to do compulsory? Yes. Otherwise, we are using the program in the calculator. When we are using program in the calculator, automatically in the third or fourth step, you will get math error. If you are using normal traditional method, it takes long time to get your final answer. This is the difference. Okay, everybody? So you want to get the answer in a quick way? Yes. So please check whether the given system of equations are diagonally dominant or not. Let me give you one equation. For example, I'll give you one equation. 10x plus 2y plus z equals 13. And example 2x plus 10y, okay, plus z is equal to 13. And let's say x plus 2y plus 10z is equal to 13. Okay, I'm just interchanging x and y. Sorry. Now look at the value of this one, 10. 10 absolute value more than absolute value of 2 plus absolute value of 1. Yes, first is confirmed. Second one, this one. Absolute value of 10 is more than absolute of 2 plus absolute value of 1. Yes, okay, good. And the third one, this is the pivotal element, or you can say diagonally dominant element. 10 must be more than 1 plus 2. Yes, it is more. So the given system of equation is what? Diagonally dominant. Yes, teacher, I know already it's diagonally dominant. I need an example for not diagonally dominant. You can say not a diagonally dominant. How to interchange rows, teacher? I'll give you an example. Okay. X plus 10y plus z is equal to 12. 10x plus y plus z is equal to 14. 2x plus 3y, right, plus 10z is equal to 15. Okay, let me check this one. Is it diagonally dominant or not? Yes. The first element is what? 1. 1 absolute value more than absolute value 10 plus 1? No. And here it's 1 which is more than absolute value 10 plus 1? No. And this one, absolute value of 10, this last element, is more than 2 plus 3? Yes, this is okay. So now you need to think about this too. So if I interchange this row to this one, what happens? Suppose I write 10x plus y plus z is equal to 14. And I write x plus 10y plus z is equal to 12. Now check it out. What is there? This is 10, which is more than 1 plus 1. Wow. And this is 10, which is more than 1 plus 1, right? So now what will be your third equation? 2x plus 3y plus 10z is equal to 15. Now this system of equations are what? Diagonally dominant. Clear, everybody? So once it's diagonally dominant, you can use Jacobi method. You can use Seidel method. So please remember carefully, because Jacobi method uses only the previous iteration or iteration values for all variables. But Seidel method uses the updated new values immediately as they are computed. Gauss-Seidel usually converges faster than Jacobi. You already experienced the situation inside the classroom. Clear, all of you? Right. Do you want one more example? Okay, let me give you one more example. Right. Let's say, okay, 2x plus 8y plus z is equal to 12, and 10x plus y plus z equals 15. X plus 2y plus 10z is equal to 20. Let me check. Am I right? So this is 2, which is more than, no, row 1 is not okay. 10, this is 1. 1 is more than 10 plus 1, not okay. And this is 1, okay, this is 10, which is, this is okay, right? So the third equation is okay. Now I need to interchange what? This and this. Let me try to interchange. 10x plus y plus z is equal to 15. 2x plus 8y plus z is equal to 12. Now check it out. Yes, 10 is more than 1 plus 2 and 8 is more than 2 plus 1, 3, right? So what is your third equation? X plus 2y plus 10z is equal to what? 20. Now this system of equation is what? Diagonally dominant. Clear, all of you? Clear? Right. So remember, my students, before starting Gauss-Seidel or Gauss-Seidel or Gauss-Jacobi, check the diagonal elements. If it is not dominant, rearrange the rows so that each diagonal element is the biggest in its row, in your row or in its row. Once it becomes diagonally dominant, your method will converge smoothly, right? I hope you understood everything, right? See you in the next video. Until then, bye bye, Zahir. See you.